Hi, I'm Paul Battaglia, and this is section 2.2. And now that students know a little bit about what a derivative is and how to use the definition of the derivative to find one, it's time to make their lives just a tad bit easier and explore some basic rules of differentiation. So the essential question you'd like your students to be able to answer is, what are some of these basic rules that will allow me to derive algebraic functions, exponential functions, trigonometric functions? So a great way to start is with an exploration. An exploration we've provided in the text asks students to use the definition of the derivative to walk through and try and find the patterns in the derivatives of some basic algebraic functions. After this, they're ready to move through examples 1 through 9, which cover the basic rules. However, students shouldn't get sloppy or complacent here, because mastery of these rules becomes very, very important as we go forward in this unit. For instance, imagine when students face more complex rules like the product rule, or the quotient rule, or even the chain rule, right? That would be kind of hard to navigate if we hadn't mastered these more common basic rules. Now, after we've covered examples 1 through 9, example 10 is a great example of how students can apply some of these differentiation rules.
It deals with rates of change, and it does deal with position and velocity.
Now, some people feel that that concept is a little overdone in calculus. So feel free to substitute your own similar examples. Perhaps you'd like to use water flowing into a tub, or the rate at which an oil spill expands or is cleaned up. In either of these cases, though, remember to still emphasize units, right? We need to make sure that students are knowledgeable about when to use units in the right context. Miles per hour, gallons per minute, barrels per second, whatever it might be. But emphasize the need for these units. Now, a nice ending to this section comes with example 11. There's a couple things we could do with this example. First off, I would have them roll through this example with pencil and paper, but when they're done, I might have them recreate it with their graphing calculator. Why? Well, on the AP exam, remember, we want them to be fluent in situations where there's a requirement or a need for the graphing calculator, and this will help them get a little bit more confidence doing that. A nice way to close the lesson is through the use of an organizational chart that summarizes motion. Have students fill in a chart that tries to summarize what velocity is doing. For instance, when an object is moving forward, or up, or to the right, we want students to be able to indicate that that represents positive velocity. And when an object is moving down, backward, or to the left, that represents negative velocity. This is also a good way to talk about the relationship between velocity and acceleration, a topic that's often tested on the AP exam. When is an object speeding up? When is it slowing down? We want students to be able to understand that an object speeds up when velocity and acceleration have the same sign, but it slows down when they have opposing signs. Finally, there are some errors that I'd like to talk about because they're very prevalent in some of these basic rules. Take, for instance, a student who needs to derive the square root of x to the third. Now, something like this, the student is probably going to rewrite first. And you'd be amazed how many times they would say incorrectly, that's x to the 2/3 instead of x to the 3/2. So watch out for that. The other thing you may have to watch out for is kind of dropping the angle in a trig function. So when asked to do the derivative of a sine function, we know it's cosine, but it's really the derivative of sine x equals cosine x. Well, why is this important that I'm making sure I include the x? Well, what happens if I'm asked to evaluate that derivative at a specific point, say pi over 4? Where would I put that pi over 4 if the x wasn't there? These are just some things you're going to want to watch out for from your students' work. I hope these tips have been helpful. I'm sure you'll find much success in section 2.2.